Hi everyone. I'm happy to be here first. I gave a lightning talk the other time, but yeah, I'm happy to be here again. So about me, my name is Olanrewaju. My friends call me Larry. Uh, I'm a software engineer at Tillo. So Tillo is a gift card and reward incentive company where you can plug into our APIs, and then you have a over 3,000 global lists to brands where you can redeem your gift card and yeah, incentives. So I'm also a co-founder at API Conf, which is a global conference that we try to like elevate API literacy across Africa. And I also blog on Free Code Camp. So I think that's all. Yeah. So yeah, I'm here to present a talk titled Securing PHP Applications with Zero Trust Principles. Yeah, so a quick introduction to Zero Trust. So Zero Trust is first originated as a security model to like enable strict access to resources across a network. But as security concerns grew, there was a need to also like move it web into the web or internet as well. So the core mantra for zero trust is never trust, always verify. Um, it ensures that for every resources or for anyone who is trying to access a certain resource, we have to like not trust them basically, and we have to like verify and re-verify to be sure they are the one or they are who they say they are. So another thing is that security should not be an afterthought. It's a core design principle. So by security should not be an afterthought, it basically says that you should not think of security later. Security should not come at the end of you building an application. It should come when you are trying to design the application, during the investigation, writing RFCs, raising your PRs. In your PR, you have like a vulnerability section where people are reviewing the PR can go to say, okay, this person has thought about this kind of vulnerability while writing this code. So it should come before or while, not after. So the next is, why do we need to care about zero trust? So like, why do we need to care? So basically, like I said, the web is very big. You have the front end, you have the back end, you have the CI/CD, you have a whole lot of things going on. Your eyes cannot be everywhere, so it means that you need to ensure that there's security at every door. So before anyone gets into the way or gets inside, you need to ensure that okay, there's proper steps you have considered or you have already taken just to ensure that you are trying to act safe. Again, you can never be safe enough, but when you keep evolving, you would get to a reasonable point. So, for instance, in this diagram I got from this Mad Devs online, uh, this shows why we should care because this is any request coming through your network. Never trust who the request is or where the request is coming from. Might be an authenticated user, might never be an authenticated user. Always verify that they are who they say they are, and they are also able to perform the actions you want them to perform, like authorize the actions just to be sure that you are the one or they are who they say they are. And then you can now grant them access to whatever they want to do on your system. So here is understanding zero trust architecture. So one is assume breach. What do I mean by assume breach? So you need to like act like your system is already breached. You need to act as though, oh, there's already someone in my system that I have to kick out immediately before maybe they can go any step further. So why does this mindset kind of help us? So this mindset helps us to stay alert and design systems with lots more security focus in mind. So while we are designing the system, and I think that there's already someone inside, what have I not thought about? So imagine you probably have not thought about refreshing token, for instance, and then there's already someone inside, and then the idea clicked. You can just quickly rotate your tokens and then have them re-authenticate again. That way, the person inside is already outside. So it helps you like stay conscious, and then while you are building or writing code, you can now think of, okay, I think I've captured this. I think I've captured this. So the next is verify, don't trust. So what does this mean? Never automatically trust anyone. So even people on your engineering team, because for instance, maybe they misplaced their device, for instance, and then someone else gets hold of it and they're already trying to like log into the system. So maybe you just want to do another level of trust to say, okay, I've sent you an OTP via maybe OT or any other third-party application, then impute the maybe 4-digit OTP just for me to be sure you are the senior engineer who wants to access my database or want to access AWS or whatever resource. So why does this also matters? People or system inside your network could be compromised too. So when they are compromised, those level of maybe multi-factor authentication would help you stay sane and check for what they are trying to do. So yeah, the next is least privilege. So why does least privilege also matter in the zero trust architecture? So it gives people or system the access they need and nothing more. So least privilege is basically saying that why does it matter? If someone account is hacked, the damage is limited and they do not have um, permissions. So for instance, an ops person in your team or in the company should not be having access as maybe a lead developer or a backend developer. So as an ops person, they have no business in maybe having access to your database, for instance, or maybe your AWS secret where you like manage your secrets. They have no access. So give them the access they just need for their day-to-day activity and nothing more. So that way, even if they are compromised, you can maybe deactivate the account and then while you get that resolved and every other part of the business still go on as usual. So what other principles are we going to cover in this part of the talk? So we're going to cover things like role-based access, OAuth 2 with scope restrictions, protecting sensitive data with OpenSSL, avoiding injection, preventing against cross-site scripting and cross-site request forgery, secure CI/CD. How can we implement a proactive defense mechanism? And we're also going to look at reward security breach in this talk alongside. So role-based access control. So on the left side, I have brought out a bad code scenario to illustrate, and on the right-hand side, I've brought out a good code scenario to help us understand what ARC-based access control should look like. So on the bad code scenario, we have a request coming in where the user is just trying to delete. So why is this code bad? I mean, you might imagine that who can write, can someone ever write this kind of code? And I'm here to tell you that yes, people write this kind of code. So, so why is this kind of code bad? It is bad because there's no authorization, no role check, and no access control logic. Now, on the right-hand side, I'm using a Laravel application here to like demonstrate. So on the right-hand side here, you can use a role-based access control. Essentially, what that means is that for anyone who try to delete this, Laravel has what we call gates. We have gates and policies. So you can define your gates within the the authorization provider, and then you define your gates to say delete post, and then on the delete post you can have a logic inside of it to say is the user ID the person who creates this post, is it equal, or is that user do they have a role assigned of admin? So in this kind of scenario now, you can now use the gate you have defined in your boot method to authorize on the delete. So by this way, doing it this way, Laravel under the hood handles your authorization for you. And if that person is not who they say they are or who they claim they are, it automatically just returns an authorization error and kick them out of your system. Why should you also use it this way? I mean, over time, right, you see some code where you have to like move that logic of the return inside of your controller. This is not so good because you are like coupling everything together. So for your authorization checks, you need to separate them away from business logic. Have a clean file or maybe a request file where you can have that logic, and that handling is done separately and not coupled together within your controller file. So that makes your work a lot more neater. And for instance, if this method has to be used in multiple other controllers, you don't need to like repeat yourself every other time. We can just call the authorized method and then it does that check for you everywhere and you are good to go. So yeah, I've also added a link to policies and gates on the Laravel documentation on this link as well. Yeah, you can check it out. So the next is OAuth 2 with scope restrictions. So why is this also important? So on the left-hand side here, I've also brought out an image of a barcode where to access a particular endpoint, which is API orders, the someone can just depend on the session middleware, and this is pretty much bad. So this is bad because you are relying solely on cookies and sessions instead of tokens. It exposes your session mechanisms in stateless APIs and not suitable for maybe mobile clients or third-party applications. So how do we check this? How do we checkmate this? How do we improve this code? You can improve this code with Laravel Passport, which is a separate package in Laravel that Laravel offers, and it offers it with full OAuth 2 server. And with Laravel Passport, you can out of the box get features like personal access tokens, scoped access tokens, token where you can actually like refresh tokens, and you can set like your TTL as well, your time to live for the tokens. This way, you're ensuring that anytime I'm generating a token, it comes with credentials where I can give to like my third parties to say, okay, if you are trying to like onboard on my system, you need to set up your client's credentials yourself. And then when you're trying to make a request to me, I know the client credentials you're using. I can verify you're the one coming into my system, and then I can get you access. And in a scenario where your clients are coming to tell you that, oh, maybe there's a fraudulent activity, you can help them with generating tokens or ask them to generate new tokens. They will authenticate themselves, and then you are pretty cool. And yeah, there's also an open source alternative for Laravel Passport as well, which I've added here in Symfony, where you can also check out. So to correct the first flaw of the previous code, this is what is going to look like in a Laravel implementation. So again, this is like not a real working code, but this is what the structure in your code should look like. So yeah, in my controller, I have tried to get the user, and I'm assuming the user already exists in my system. And what do I do next? I can now attach like the setting scopes to that particular user. So if that user is up, maybe it has a role of admins, then I can read my scopes maybe from the database to say, oh, for this particular user who I've identified to be a master user, for instance, I can get them the scopes of maybe read orders or view profile, and then I can go ahead to create the tokens. So these tokens will now be used to make the request. So on your middleware, you can attach the scope to your middleware and say auth API, and on the auth APIs, you are going to attach the setting scopes needed to perform that action. Then from the person who is making the request, maybe from the front end or from your third-party application or from your mobile application, they just need to attach the bearer or access token, which already ships with the scopes in your authorization headers. And then this way, you already know who is coming, you have verified them, and then you let them carry out the action, which is lots more better and lots more safer than the previous code where you're just basically relying on sessions. So the third one is protecting sensitive data with OpenSSL. So why is this also important? So this is important because on the first bad code here, I'm trying to do like a set content and a get content. So but what I'm doing here is that I'm assigning the value to a value which is a plain text to certain parameters. So again, when you are trying to like work with we all work with data here, and it's going to be a bad deal when maybe the government come for you to say, oh, there's a breach, and then people's account numbers or their transaction record or sensitive personal identifiable information is out there in the world. So you want to like prevent against this. So if the value, for instance, is very sensitive data, like or account balance, account number, or a payload for a transaction with maybe their card details and whatnot, you want to ensure this kind of sensitive data are properly kept, and they are not they don't get into the wrong hands, basically. So this is where encryption comes in. So encryption is basically a way to like shield away data that are coming in human form, and then you can decrypt it or encrypt it into a form that only you understand. So that way, you are decrypting it with a key, a certain key, and then that key would also be used again to encrypt it when you need to, like, maybe return or retrieve the data. So that is what OpenSSL ships with. So OpenSSL is a open source cryptographic library that implements SSL and TLS. So why is this good, or why should we use this, or why is it a standard? It helps you keep confidentiality. So like user data, they are kept secure. It is only known to you yourself, and you can also, like, decrypt it. So it also prevents against data leaks. So people's personal identifiable information that can be used to maybe cause harm or danger can be kept away. And also encryption and decryption. So in PHP, use OpenSSL encrypt if you're maybe writing raw PHP without library. Use OpenSSL encrypt to encrypt the data, and OpenSSL to decrypt the data. So in the next slide, we are going to look at how we can correct this bad code using an example. So yeah, so in this bad code, for instance, on the left-hand side here, I'm using a Laravel application here. So in Laravel already ships with a facade called decrypt facade, CRYPT. So if you are using Laravel, all you just need to do is use the facade, and there is a static method on it, which is encrypt. And then the encrypt basically works with strings, payload, which is maybe in JSON. You can JSON encode it and then call the encrypt method on it. And when you are trying to, like, get the data back, you can also call decrypt, then the decrypt method, which is a static method again on the crypt file. Then you can pass your value to it to get the return value. So like I said initially, you need a cipher key, right? So the default cipher and key are configured within the config app of your Laravel file, where you can set that up. Then on the right hand side is a Symfony example, because I'm conscious not everyone in the audience here uses Laravel, but we also have a Symfony library as well that does similar. So you can check out the library specs shaper. So what it basically does is when you import it, then you call the encrypt annotation, which is very important. And under the hood, Doctrine encrypts and decrypts for you. So you don't need to, like, manually call crypt dot encrypt in Symfony. You just have to, like, do it on the right hand side. Again, worth noting that values you want to encrypt or decrypt should be personal identifiable information, like very sensitive data that you don't want to go into wrong. And so that is the kind of data you would want to ideally encrypt and decrypt. So, and also under the hood, those libraries use OpenSSL. So, which, because again, is the standard. So next is avoiding SQL injection. So so here is, these are like two different bad codes. So why are they basically bad? So the first is I'm number one, straight up trying to trust the user inputs to say I'm trying to post in a select, then basically this can lead to SQL injections, right? Because I don't even know what I'm even trying to read from the database basically. So on the right hand, oh yeah, here now. So what have I done to correct that? I'm trying in a Laravel application. Your Laravel has a validate method where you can basically say, okay, I want to validate this. I want it to be a string, and I want it to be an email. So this email basically ensures that it's a valid email address and not anything malicious. So then I can go ahead to get my what's it called here, my records. So on the right hand side as well, from PHP 8.2, we have the execute query, which basically prior to PHP 8.2, if you write over PHP, you need to do the bind, you need to do other things. But with execute query in PHP 8.2, all those steps, bind, get data and whatnot, prepare, bind, those has been handled out of the box. So if you're using Laravel, for instance, there's also a link to more validation rules that applies to your applications. So the next is preventing against XSS, which is cross-site scripting and cross-site request forgery attacks. So this is a code where I've been able to show for instance, I'm trying to render data into my bleed file using just echo. So why is this bad? This is bad because I'm not. So what if the data I'm trying to print out contains some malicious JavaScript or HTML codes that I don't want to render? So what you can do is to use the double curly braces in Laravel, for instance, which under the hood also uses HTML special class. And also, if you are trying to like post, ensure you have like maybe a TSR represent, which basically is a token you have generated from the backend, and then you're sending to the front end, which front end now send to the backend where you can easily authorize. And also try to implement content security policy, which basically tells your applications what type of where your script should be loaded from. And yeah, so you can help prevent your application. The next is secure CI/CD. So secure CI/CD is about like again, a couple of us we are already moving to CI/CD, continuous integration and to continuous deployment. What are some of the things to note in mind? So you should never commit your env to Git. You should only have like your env.examples in your Git. Also, when you're trying to set permissions in your cloud, you should not do or action the wildcard or resource the wildcard, which basically means everybody has access to all the resources. So you want to ensure that you are specifying what actions a user should have. So if maybe a user should just have access to put content in the bucket, S3 bucket alone, or maybe if your user should basically just have access to maybe just your AWS secrets, for instance, or whatever. So, and also coding secrets in YAML is also bad. That can not be emphasized enough. You can do this by using AWS or Google Cloud Secret Manager or Azure Key Vault to ensure that your secrets are properly kept safe and they are not be used for other alternative uses. So how can we implement a proactive mechanism? So implementing proactive mechanisms goes beyond just writing code. It goes towards like monitoring that certain things are being logged properly. You can monitor logs with maybe Datadog or API toolkit. Ensure that high priority errors are being returned to maybe Slack, and then you can have engineers maybe weekly or weekly rotate the Slack channel to maybe monitor logs as they are being reported. And we also want to ensure that you are auditing properly. For every action that is going on your system, post requests, get requests, ensure you are auditing. Laravel audit helps keep track of before changes and after changes, and you can easily refer back to them if you want to. Don't trust the front end. Don't assume all the data is coming from the front end are kept safe and secure. You should also try to validate all incoming requests. For you, those of us that use maybe Telescope or Horizon, for instance, or maybe Dash Admin for admin, don't do this because it is not safe. Ensure people coming to those places are who they say they are. And also build a robust incident response plan. So when an incident happens, basically, you want to ensure that there is proper communication with maybe your clients. You don't just have to keep them in the wild and then they are left wondering why your API is down for 30 minutes an hour. So build an incident response plan, create a incident response page detailing what happened, what measures you have taken, and then within the team, create a team channel where you can come together to talk about that incident, why did it happen, and the next step where you can take to combat that next time. So this is also continuous security testing. Like I said, maybe you're building like a banking application. You don't want to leave your tokens to be 3 hours and stuff. You need to rotate it. When you notice there's an idle management in a state, you regenerate the token, you refresh the token. That way people are who they say they are. You're like monitoring for things. So also in your pipelines as well, you need to like, if you're using, everybody uses Composer or NPM, add NPM audits or Composer audits to your pipeline. That way you are staying ahead of vulnerabilities. So some of all these packages, they tend to be vulnerable. People report vulnerabilities every now and then you need to also know what to do. So by integrating it into your pipeline, you can know when the pipeline, because it's going to report it in the pipeline, because it's going to run like Composer audits for you, and then you can see vulnerable packages, what you need to do. Maybe you need to bump it to a higher version or a latest version or a patch that has been released, and you can do that to help you. So so this is a reward scenario of how everything we've been talking about come together. So this is a security breach that happened in GitLab in February 2025, and they paid a bounty of $35,000. So what's happened? So HackerOne is a platform where people report vulnerabilities. So if maybe you're a bounty hunter kind of person, or you can go there, look for bugs, you report it. When you fix it, you get paid. So so they reported a account takeover by password reset, where the person posted an email with a victim and an attacker at gmail.com, basically as an array. So in a real world, you might imagine who would allow this go through, but they did. So, what would have been the best case to have handled this? Again, the person was posting an array. So, what you should have done, or what I would do to prevent that from happening, is that I would validate that it should be a string and a valid string at that. I'll get the user and only make sure I'm sending the reset password to the authenticated or to the user I'm finding in my database. I would not just assume that, oh, because this person has sent me an email, then I send them the reset password. I would first check the database for the email. If I can find it there, I would send the reset password, make an audit of that event, and then I would return a password reset. So if that user is not found, basically this block would not execute, and then all they just see is password reset. Maybe the attacker will just see password reset, and then they will just assume maybe that particular feature is not working. So that would have prevented that from happening. So the last one is the security breach that was also found on HackerOne itself, and they paid a bounty of $25,000. This was reported in April 1, 2025, just last month. So what did they do? What did they do wrong? So on this endpoint, dash report endpoint, they were returning user informations, personal identifiable information that I was talking about just earlier, OTP backup, reporter's phone number, the secrets. So the person reported it, and everybody were quite surprised. Okay, what's going on? Why do I have access to and someone else's phone number? So what they should have done was that in Laravel, you have an attribute called hidden, where you can use to hide certain fields you don't want to be returned. So when you call the model report, for instance, this hidden field ensures that this data I've set to hidden never gets returned. But if I know I still need that data, I can just maybe use select, or maybe if you use over PHP or Symfony, for instance, select this actual field you want, and then you return it, and also ensure that on your endpoint, the person who they say they are, you've wrapped it in your scope, and then you can basically show it to them. So my time is almost up. So this is zero trust to recap. So what are the things we've talked about here? Never trust, always verify. Enforce least privilege, like I said earlier. You need to monitor continuously. And we have also learned about API access, role-based data encryption, invalid validation, and there is also a meme. I love memes. So so you should not turn app debug to train production. Don't try that. And yeah, you should also always stay false. And yeah, so final thoughts and QA then. Thank you.